Let's go to page 722 and start with number 1. It says, in a standard normal distribution, what percent of data is between the mean and 0.4? Okay, what you do is, again, you draw the picture so you can visualize. Okay, so the middle is your 0 standard deviation, and you're looking for from between the mean and the 0.4. Okay, so you're looking for between 0 and the mean and the 0.4. So you're looking at this area. So you go to the table and you look up the number. So you look up the 0.4 is 0.1554. That means this area is 0.1554. Okay? And if you convert into percent, so this gives you 15.54%. Okay, and that's it. Okay, so that's your answer. Okay, so let's go to number 3. Again, you need to draw the picture so you can visualize what area you're looking for. Okay. Number 3. Okay, so what percent? So you can get your bell curve. Okay, so you're looking for between the 3 and 4 standard deviation. Okay. And so between 3 and 4 standard deviation below the mean. Okay, so here's the mean. So you're looking for between 3 and 4. So here's your minus 3 standard deviation because it's below, so it's negative. Okay, and it's negative 4 standard deviation. So you're looking for between 3 and 4 standard deviation below the mean. Okay, so that's what it means. Okay, so again, you go to the table, you look it up. Okay, so this number right over here. Okay, so 3.0 again you can just ignore the negative. So you just look up 3.0 is 4987. Okay. Okay, so that's 0.4987. That is this area here. And the entire area, so it's look at negative 4, so 4.0 is 0.5000. So this is 0.5000. Okay? So this area would be equal to this minus that. Okay? So the area you're looking for, you call it x. So x will equal to 0.500. That is this whole thing minus this will give you that. Okay. So x will equal to, so you subtract, it would be equal to 0.0013. Okay, and convert into percents, so it would be equal to 0.13%. So convert decimal to percents, you just move decimal 2 places over. Okay. So again, you need to draw the picture to visualize what you're looking for. Okay, so you can figure out what you need to add or subtract. Okay, let's go to the next one. Okay, number 5. Okay, so this one you can't have to read through, and you have to write down all the information. It says the mean weight of the loaf of the bread, so mean, so that's the M, equal to 455 grams. Okay? And with a standard deviation of 5 grams. So standard deviation equal to 5 grams. So assume a normal distribution, find the percent of loaf for each with the weight that are. Okay, so A, you're looking for the weight is less than 450 grams. Okay, so again, you have to write down all this information. So next, what you need to do is you have to convert the actual weight into the differential. So 450 compared to 455 is minus 5 grams. So that means the weight you're looking for is 5 less than the normal, or the average, okay, the mean. Then after that, so again, convert this into the differential, the difference. Then after that, your next step is you convert that into deviation. So one standard deviation is 5, and so this will become minus 1 standard deviation. Okay, so first you find a differential, so this is 5 below, and then you convert into standard deviation. The next step is you go and draw your bell curve. Okay, so here's your 0, here's your mean, the middle, and here's your negative 1 standard deviation. I can just find a random place and just draw it. This is just so you can visualize. And less than that would be over here, right? So again, you have to use this to figure out what area you're looking at. Okay? Okay, so now you have to go to the table, so -1, so you look up 1 is 3413. So this area over here is 0.3413, okay? But to get this area, you need to use this whole thing right over here, okay? So this whole thing is half. So it's 0.5000, okay? Again, because the whole thing is 1, so half is 0.5. So the area looking for over here, the x, the percent, the x will equal to 0.500 minus, so again, this is 0.5, so use this, minus that will give you that. So minus 0.3413. So so the part A, the x you're looking for is 0.1587. And you convert to percent, so it would be 15.87%. Okay, so that's part A. Okay, let's go and do part B. So 5B, again, the M equal to 455 grams, and standard deviation equal to 5 grams. Okay, so part B, you're looking for the weight is greater than 445 grams. Okay, so again, first you need to convert into the differential. So this is 10 less than that. So again, you have to minus that. So this is minus 10 grams. Okay, and then after you have to convert into standard deviation. So what you're doing, this process is called a normalizing. Okay, and so one standard deviation is 5 grams, so 10 grams would be minus 2 standard deviation. Okay, so again, you draw your picture. So here's your 0. So minus 2 is right over here, minus 2 standard deviation. Okay, so here's a minus 2 standard deviation, and you're looking for the weight that's greater than that. So greater than that is this entire area right over here. Okay. Okay, so again, you look up the table. So this part right over here. So again, the table you get is from the 0 to whatever the value you're looking for. So minus 2 is because remember they are symmetrical, right? So you're looking for the 2.0. So look right over here. So this will give you 0.4772. Okay? So that is this area, this half right over here. And this half, well, half is what? Half is 0.5000, right? Again, the whole thing is 1. Okay? And so this is half, so it's 0.500. So that means the x you're looking for will be adding these two together because you're looking for this whole thing, right? So again, that's why you have to draw your picture and to figure out, to see what you need to add or subtract. So this will equal to 0.4772 plus 0.5000. So x will equal to 0.9772, okay? And convert to percent, so it would be 97.72%. Okay. Okay, let's go to C. Okay, so 5C again, write down all your information. So again, the mean is 455 grams. And one standard deviation is 5 grams. Okay, so 5C, you're looking for the weight is greater than 470 grams. Okay, okay, so you can first, you change this into differential. So this minus that will give you plus 15 grams. So in other words, this is 15 above the average. And then this would be greater than, so you have to convert into standard deviation. So one standard deviation is 5, so plus 15 will equal to plus 3 standard deviation. Okay? So again, this is called a normalizing, so you can use this table over here. So here's 0. So plus 3 is going to be somewhere over here. Again, it doesn't matter, just put a random point and call this plus 3. Okay? This is just so you can visualize what area you need to get. Okay, so here's your plus 3. And you're looking for greater than plus 3, so you're looking for anything over here, right? Again, this side is greater than, this side is less than. So now you can look up the table. So when you look up the table, the plus 3, the 3.0 is 4987. So this over here is 0.4987. Okay? So the area you're looking for, this whole thing is half. It's 0.5000. Okay? So the area you're looking for, you have to use this minus that, right? This take away that will give you that, right? So you're going to have an x is going to be equal to 0.500 minus 0.4987. Okay? And so x will equal to 0.0013, so it'd be 0.13%. Okay. Okay, let's go to 5D. Okay, so you can copy all the information. Okay, so for D, you're looking for between 450 and 460. Okay, so 450 and 460. So the weight is going to become between 450 and 460. Okay, so you can do it exactly the same process, right? So 450 is minus 5, right? So minus 5 grams. Okay, 460 is plus 5 grams. Right? This is below, this is above. Then you have to convert into standard deviation. So minus 5 is minus 1 standard deviation. Plus 5 is plus 1 standard deviation. Okay? Okay, so draw your picture. Okay, so here's your minus 1 standard deviation. Here's your plus 1 standard deviation. Again, here's your 0, right? Minus 1, plus 1. And you're looking for everything in between, right? So between this, so it means you're looking for at this area. Okay? So now if you look at the table, so 1.0 is 3413. Okay? So this is 0.3413. Okay, and this is the same, right? So 0.3413. Okay? Because they are symmetrical. So the x you're looking for would be 0.3413 plus 0.3413. So x will equal to 0.6826. Convert into percents, so you got 68.26%. Okay. Okay, let's go to number 7. Okay, number 7A. It says the mean life of a certain kind of light bulb is, so the mean is equal to 900 hours. Okay? And with a standard deviation of 30 hours. So standard deviation equal to 30 hours. Okay, and you know, we learned how to figure out these from before, right? So they kind of just bypass all that already. They just give you these. Okay. And so part A, you're looking for assuming the life, so I'm going to call it L. So you want the life is less than 900 hours. Okay? Okay, so convert it into the differential, so this will equal to 0, right? And convert that into standard deviation would be equal to 0 standard deviation. So when you draw that, okay, here's your 0, and you're looking for every less than that, okay? Well, this is obvious that this is going to be half, right? So answer would be equal to 0.5000, okay? Because remember, the entire thing is 1. So half of the graph is 0.5, okay? Convert that, okay? So convert that into percent, so it'd be 50%. Okay. Okay, 7B. So again, the mean equal to 900 hours. Standard deviation equal to 30 hours. And so you're looking for the life that is more than, so it's more than means greater than 984 hours. So looking for the percentage of the light bulb that would be lasting more than 984 hours. Okay, so you can change into differential. So this minus that will give you 84 plus 84 hours. Okay, and convert into standard deviation. So you have to divide. So get your calculator. So 84 divided by 30 equal to 2.8. So this, what am I doing? So this will be greater than 2 plus 2.8 standard deviations. Okay, because 30 hours is one standard deviation, just one divide. Okay, so again, first you find the differential, and then after you convert into standard deviation. Okay, so you can just pick out a random point over here. You just want to draw pictures so you can visualize. Okay? Okay, so now you go, so you're looking for greater than, okay? So you have to figure out, okay, which area is greater than 2.8? Well, here's your 2.8. So greater than is this area right over here. So when you look up the table, the 2.8 is 497, this is 0.4974, okay? So the area you're looking for is this over here. So your x rate equal to 0.5000 because 1/2, right? This is 0.5, and you take away that, so it'd be minus 0.4974. So x rate equal to 0.0026. So convert that into percent, you're going to get 0.26%.